questions focused on the toxicity differences between exotoxins and endotoxins, particularly their lethal dose levels. Question 1. Lethal dose of exotoxins. A lab worker accidentally injects a small amount of purified botulinum toxin into her finger while handling research samples. She quickly develops flaccid paralysis and is hospitalized in critical condition. Which of the following best explains the severe systemic effects seen with only a minute amount of this toxin? A. The toxin is heat stable and accumulates in tissues. B. The toxin is highly antigenic and induces cytokine storm. C. The toxin has extremely high toxicity with a very low lethal dose. D. The toxin is a structural part of bacterial membranes. E. The toxin induces autoantibodies that mimic neurotransmitters. Correct answer C. The toxin has extremely high toxicity with a very low lethal dose. Explanation: exotoxins, such as botulinum toxin, are highly potent, with lethal doses in the microgram or even nanogram range. This explains severe systemic effects even from small exposure. A. Botulinum toxin is heat-labile. B. Cytokine storms are more typical of endotoxins. D. Endotoxins like LPS are structural. Exotoxins are secreted. E. Not a relevant mechanism here. Question 2. Comparative toxicity of endotoxins. A 55-year-old man is admitted with sepsis caused by Klebsiella pneumoniae. He develops a fever, hypotension, and elevated pro-inflammatory cytokines. He is treated supportively and recovers. Which of the following best describes why a relatively large amount of endotoxin is required to produce life-threatening effects? A. Endotoxins lack enzymatic activity and are poorly absorbed. B. Endotoxins are rapidly degraded by the liver. C. Endotoxins have low toxicity and require high concentrations to be fatal. Endotoxins are neutralized by preformed antibodies. E. Endotoxins are confined to intracellular compartments. Correct. Endotoxins have low toxicity and require high concentrations to be fatal. Explanation: endotoxins, particularly lipid A from gram-negative bacteria, are less toxic than exotoxins. They require much higher concentrations to produce fatal effects, often the range of hundreds of micrograms. A, B, D, E. Not accurate mechanisms or explanations for endotoxin behavior.